Hey, hey, hey. We are going to do a complete hypothesis test. So go to your page 12 of your notes and let's look at the bottom, number 40. Now please read over it and also highlight the key information. I've already started, but I noticed there's a couple other things I want to highlight. So you go ahead and do your annotations and highlights. Now, this whole premise surrounds the idea that the drug manufacturer claims that less than 10% of its patients who take its new drug for the treatment of Alzheimer's will experience nausea. So his premise is that less than 10% is going to experience nausea. So they took a random sample of 300, and that was out of 5,000 Alzheimer's patients. So that's the entire population right there. And in all, they found that 25% experienced nausea. So we're going to be performing a test at an alpha level, a level of significance of 0.05. Now, based on everything I just stated, our first step, it is a 1 proportion Z test. Our HO is that the proportion is going to be 10% that are nauseous, so that's the off the regular medication. But the company said that they have new medication now that's going to be less than 10%, and this is what the company's claim is right here. Where our true proportion is the 5,000 Alzheimer's patients who get nauseous while taking the new drug. That is what we're looking at. That's our step 1. Now let's look at our step 2, our conditions and assumptions. And as we look at that, remember the idea of looking at our sins. Okay, so here random sample was given. I was thinking that it was random allocation because they randomly chose who they were going to be giving the medication. But you don't have to worry about that. What I've just checked off is sufficient. Independence. Remember, the whole idea behind independence is determining randomness. But here, your entire population of Alzheimer's patients in this particular scenario, there's only 5,000 of them. And here is the sample that we chose out of the 5,000. So let's make a note here. That is our 10% rule. And now let's look at normality like we have always. Here we're looking at n times p, not p hat, but n times p. That is greater than or equal to 10. Yes, it is. So yes, it is approximately normal. So here, therefore, I can proceed with this test. Step 3 is the calculations. So remember, here is our formula for the Z test. So we've got P hat, which is the sample, which is the information right here, the 25 that were nauseous out of the 300 that were randomly selected, minus the population. Remember, the population is always the P that is up here, that is the 10%. So this value is going to always be the same. This value right here is going to always be the same as this value right there. Okay? And which is going to be the same as this right here. Because remember, this is all about the population. No hats, no hats, no hats. Take those hats off, people. Okay? And then here we do the math, and this gives us a z-score of 0.96, and of course that is a negative. Then what we have to do is use our chart to find the probability of the z-score being a negative 0.96. And we find out that this is going to be 0.1685. So let's see how we find it on the chart. Let's remind ourselves. Okay, we're looking at our z chart, our z distribution. We slide down to a negative 0.9. Remember, we need to be on the negative side. Then I slide over, kind of doing a down and over thing combined to get the 0.1685. Now here's the thing. The original HO was that the P is less than. So that means as I draw myself a bell curve, we are looking at it being a left tail. And that probability right there is literally going to be the values right here in that tail, just so that we can connect our prior information to what we're doing now. And if you really want to consider it, that z-score is right here, the negative 0.96. Because honestly, if we don't get that aspect, it's not a big deal. It is helpful to bring it together in terms of not making, to catch yourself in an error. The picture is nice, but knowing that that's a negative 0.96, if you don't quite get that, you're okay. Now, since we have that, remember here, this is our p-value. And what we've done when we discuss the p-value is we're not looking at a graph. We just determine, we compare our p to our alpha, and here, since our p-value is greater than our alpha, we're going to fail to reject the HO. And as we fail to reject the HO, that means at the same time we are going to reject the HA. And so what are we rejecting here? We're rejecting that it's less. We're rejecting that this new medication that claims to decrease the nausea, it's not happening. So as I read the final conclusion, as you can see, we have no evidence to suggest that less than 10% of those, 5,000 Alzheimer's experienced nausea while taking the new medicine. And please remember, if your thoughts are Sharba, we only had a sample of 300, but this is the idea. Remember, as we have a sample, we said if it's true for the sample, it must be true about the entire population. So there it is in a nutshell. Be ready on Monday to discuss any questions you guys have. Have a great weekend.